Let's move on to question number 178. The question says that iron exhibits BCC structure at room temperature and above 900 degrees centigrade, it transforms to FCC structure. Then the ratio of density of iron at the room temperature to that of 900 degrees centigrade. So basically the density of BCC structure to the density of FCC structure. It's a pretty straightforward because you have a direct formula for density which says density is equal to Z into M upon Avogadro number into A cube. This is a simple, pretty straightforward formula which comes directly from the NCERT book. Now, what happens is for BCC structure, you have Z is equal to 2, Z is equal to 2, and A is equal to 4R by root 3. And for FCC structure, you basically have Z is equal to 4 and A is equal to 4R by root 2. So this is how, so if you realize that my Z is the factor which changes depending upon the type of the cell my metal is getting crystallized in. M is going to stay the same because it's basically for the iron, and Na is my Avogadro number, so once again it is going to stay the same. So all I have to calculate is, as I told you, at room temperature it is in BCC, so density of BCC upon density of FCC, which is equal to, I simply have to substitute this and this over here. So Z upon A cube, so that is 2 upon 4R by root 3 the whole cube divided by, for FCC I have Z is equal to 4. So Z is equal to 4 divided by A is 4R by root 2. So this is 4R by root 2 whole to the power of cube. I'm sorry, this is not 2. This is my cube. On solving, you get 3 into root 3 upon 4 into root 2, which is your option number 1. So this is your final answer. The ratio of the densities are pretty straightforward. So from solving simply this, you will get the option number 1, that is 3 into root 2 upon 4 into 3 into root 3. That's once again my bad. 3 into root 3 upon 4 into root 3. So this is option number 1 for question number 178.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.